Hello. In this video, we'll be going over the North Carolina Released Common Exam Math 2 problems 9 through 11. You can find information about this common exam and other common exams by following this web address right here. Let's get started. Alright, so for this one, it's wanting to know which equation has exactly one real solution. Now, all of these equations are quadratic equations, and we can tell how many solutions a quadratic equation has by looking at the discriminant. Now, for those of you who don't remember what a discriminant is, it's the part underneath the radical in the quadratic formula. You should be able to remember the quadratic formula. Uh, most teachers go through a lot of effort to help kids remember the quadratic formula. Uh, I use a song, well, a couple of songs. I think the more popular one goes to the tune of Pop Goes the Weasel, and it goes like this. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Alright, so that's the quadratic formula. So the discriminant is the part underneath the radical, this b squared minus 4ac. Now, if the discriminant is 0, then there's only one real solution. Alright, if it's positive, there's two real solutions. And if it's negative, there's no real solutions. So we want to see which ones, or which one out of these equations has 0 as the discriminant. So all we really need to do is pick out the b, the a, and the c, and plug them in right here to b squared minus 4ac, and see which one gives us 0. Alright, this is one of those problems where it's actually 4 problems mixed into one question. So we got to go through each one and see if they work. Alright, so let's start with the first one here. So this is A, this is B, this is C. So we have negative 12 squared minus 4 times A, which is 4, times C, which is negative 9. Negative 12 squared is 144. And then negative 4 times negative 9. Well, here we have a negative times a negative, so that's going to be a positive. And even though 4 times 4 times 9 is 144, we have plus in the middle, so this is going to give us 288, which is positive, so that means this one has two real solutions, so it's not going to be our answer. Let's try B. Alright, so for B, once again, we got a positive 12 this time as our B value. So we've got positive 12 squared minus 4 times A, which is 4 in this case, times C, which is positive 9 this time. Okay, 12 squared is 144. This time we've got negative 4 times 9. It's just going to stay negative because there's only one negative in this multiplication. And it gives us 144. 144 minus 144 is 0. So this one only has one real solution. It has exactly one real solution. Alright, now it's always good to check all your answers to see if they would work. So let's try C and D. Now for C and D, the only thing different is the value of B. So the only thing that's going to be different is this front value. The back value is still going to be 144, but the front value is now going to be 6 squared, or negative 6 squared, which is just 36. So neither one of those is going to work either. So B is our answer for this problem. Number 10, a circular pond is modeled by the equation x squared plus y squared equals 225. A bridge over the pond is modeled by the segment of the equation x minus 7y is equal to negative 75. What are the coordinates of the points where the bridge meets the edge of the pond? Alright, so I'm going to go through and want to highlight some key information here. We've got a circular pond modeled by this equation right here. A bridge over the pond is modeled by a segment of the equation, and it gives an equation. What are the coordinates of the points where the bridge meets the edge of the pond? Alright, so this is one of those, when in doubt, draw it out. So I'm going to draw me a pond. Let's see, let's make it have some blue water. Alright, so here's our pond. Now we have a line segment going through the pond. Alright, we want to figure out the places where it crosses or where it intersects the edge. So we want to find out this place in this place. Now, we could graph this. If you're really good at solving for a variable in quadratics, you can actually graph the circle and the line and see where they intersect in a graph. But I think it's much easier to do this algebraically. So now that I've got an idea of what it looks like, I'm going to solve this using substitution. All right, so I'm going to solve this equation for x. I'm going to plug it back into the top equation to figure out what y is. So we've got x minus 7y is equal to negative 75, which means that x has to equal 7y minus 75. I got that by adding 7y to both sides. So now I take this value right here and I plug it in where I saw the x in this equation. So I'm going to take that x out and I'm going to plug in 7y minus 75 right where it was. Alright, so we got 7y minus 75 squared plus y squared equals 225. Alright, now I have to simplify this. In order to simplify it, I'm going to square this part. Now when you square this part, you have to multiply it by itself. You can't just square each individual part. It doesn't work that way. So we've got 7y minus 75 times 7y minus 75. Alright, so here we go. I use kind of like FOIL, but I call it the multiplication missile, so I'll make that little noise. 7y times 7y is 49y squared. 7y times negative 75 is going to be, let's see, negative 525. So negative 525y. That's going to be the same thing, negative 525y. And then negative 75 times negative 75 is positive 5,625. Alright, so I'm going to take this and I want to put it back into our equation because all we were doing right there was just simplifying this part. I'm going to combine like terms as well. Let me do that before I put it back in. So we got 49y squared. When I combine these two, I get minus 1,000. Hold on just a second. Sorry about that. I keep pushing the wrong button on my tablet here. All right, so back to what I was saying. So we're simplifying, we're combining like terms. So we get negative 1,050 y plus 5,625. That's what I'm going to put back where this 7y minus 75 squared was. All right, so we have 49y squared minus 1,050y plus 5,625. Okay, that was just this part right here inside the parentheses squared. All right, so now I have to put the rest of it back in. So plus y squared is equal to 225. All right, so once again, I'm going to combine like terms. 49y squared plus y squared is 50y squared. So it's minus 1,050y plus 5,625. It's equal to 225. Alright, so now I have a quadratic equation. All this way just to get a quadratic equation. We know how to solve quadratic equations though. We have to get it equal to 0 first. So I'm going to start by subtracting 225 from both sides. And we get 50y squared minus 1050y plus, and that's going to give me 0, 0, 4, 5,400. Alright, so that's equal to 0. Now, my favorite way to solve quadratic equations is just by factoring if it's possible. So what I'm going to do is I'm going to try to factor this first. Now I notice that 50 goes into all three of these things. So I'm going to factor out a 50 as my very first step. Alright, so I factor out a 50. So I get y squared minus 21y plus 108 is equal to 0. All right, now I'm not done factoring yet. I want to find factors of 108 that give me 21 when I combine them, when I add them together. All right, so 108, the factors of 108 are 1 and 108, 2 and 54, 3 and 36, 4 and 27, 6 and 18. 4 looks like a 9. It should be 4. 6 and 18, because 9 is a factor. 9 and 12. All right, so looking through here, looking for ones that add up to 21, 9 and 12 are the winners. So when I factor this, I get 50 times y, and since this is a negative right here, it's y minus 9 and y minus 12. All right, now the zero product property says that if we have things that are multiplied together that give you 0, then one of those things has to be 0. Well, I know 50 can't be 0, so I have to figure out when is y minus 9 equal to 0, and when is y minus 12 equal to 0. All right, so for this one, adding 9 to both sides gives us y is equal to 9. Okay, on this one, adding 12 to both sides gives us y is equal to 12. So those are my two values for y for this problem. All right, so to find the x values, you simply take this 9, plug it back in to one of these equations. I would plug it in right here because it makes it a whole lot easier since you've already solved for x. But you can plug it in anywhere you see y. You can plug it in here, you can plug it in here, you can plug it in here, anywhere that still has an x. Okay, so when you plug that in, you get negative 12 for the x. And then when you plug in 12 for the y, you get 9 for the x. All right, now one thing I could have done is I could have stopped right here though, because looking at my answers, there's only one answer choice that has positive 9 and positive 12. Well, actually no, there's two. My bad. So I would have to plug them in and see. I would have to plug in the 9 to see. So let's go ahead and do that anyway. So what I want to do is I want to take this 9 here. I'm going to plug it in for y right there. So we get x is equal to 7 times 9 minus 75. Okay, so 7 times 9 is 63. 63 minus 75 is negative 12. Okay, so the point negative 12, 9 is one of the points where this bridge meets the edge of the pond. All right, so that means my answer has to be A, because even though B has the right y values, it doesn't have the right x value for that. Number 11. The volume V of a certain gas varies inversely with the amount of pressure P placed on it. Okay, so this is inverse variation. The volume of the gas is 175 centimeters cubed when 3.2 kilograms per centimeter squared of pressure is placed on it. What amount of pressure must be placed on 400 centimeters cubed of this gas? All right, so highlighting keywords, the volume V of a certain gas varies inversely with the amount of pressure P placed on it. The volume of this gas is 175 centimeters cubed when 3.2 kilograms per centimeter squared of pressure is placed on it. What amount of pressure must be placed on 400 centimeters cubed of gas? And all I was doing there was I was just highlighting key information. Now, this is apparently saying that there's the same amount of gas. We want to see how much pressure would be placed on it to get it to fit in this much volume. All right, so varies inversely means that V is equal to something divided by P. That's what inverse variation means. To figure out that something, we're going to have to plug in values for V and P and solve for K. All right, so the volume is 175 when the pressure is 3.2 kilograms per centimeter squared. All right, so to solve for K, I want to multiply both sides by 3.2. All right, and so when I do that, I get K is equal to 560. So plugging that back into my original equation, we get the volume is equal to 560 divided by P. All right, so I want to know what pressure must be placed when it's 400 centimeters cubed of this gas. So we got 400 for the volume is equal to 560 divided by P. Solving for P, I'm going to multiply both sides by P. And I'm going to divide both sides by 400, so I get P is equal to 560 divided by 400. All right, and so that gives me 1.4 when I do that division. So it's 1.4 kilograms per centimeter squared. So the answer is B. Okay, remember if you have any questions, feel free to comment on the video, and have a good one.